Okay, the second concept I want to share with you is the phenomenon called diffraction. In Korean, it's called 패절. And diffraction is a fundamental aspect for us to understand why and how images can be formed in microscopic imaging. So for that, I just want to show you and bring an example picture from the nation. So there's an ocean wave, and here, the ocean waves come in and it hits this land, but the shape is here, there's an opening there. And what's interesting is now the waves are actually making a circular pattern. So originally it was a plane wave coming in, and then once it hits this obstacle, and especially the slit-like structure, and now the wave form is changing towards this circular format. And that bending of the wave we call diffraction. And here I'm not talking about light. This is a water wave. However, light wave phenomena are common, and this exactly applies when the light moves and it hits an obstacle. But now I'm talking very tiny openings, which is comparable to the wavelength of the light. Otherwise, we usually consider light as a propagating like linearly, okay? But look at that. So this little bar is in fact representing wavefront, meaning the same phase. So each bar distance represents a wavelength. So we can see how small these are. And I want to compare these ones. So these two has the same kind of wavelength of light. But if the opening is there and comparable to the wavelength, you see they start to bend, just like the one previously in the ocean. What if this slit size is smaller and smaller, and even it's almost comparable or smaller than wavelength? You see the bending is more. Okay, then let's go back to the original one. The same opening and this. Now let's change the light wave. So let's increase the wavelength. Then you realize it becomes bending more. And also this one is the same. So here, what kind of lesson we are obtaining? First of all, diffraction is the bending of waves around an obstacle or through a hole. Okay, so that's a fundamental properties of wave when it interacts with an obstacle. And this is actually an experiment. And what it shows is, first of all, with the same opening, if we use a longer wavelength, you see it bends more. So that means diffracts more for longer wave. Okay, so, but what about for exactly the same wave, the relative size of the hole, when it gets smaller, it diffracts more. So what I want to say here is the diffraction phenomena, what it determines the phenomena is the relative size, length of the wavelength, and the relative size of the obstacle opening. So that determines this diffraction. And this is very important phenomena that determines our resolution of optical microscopy. And later I will point this out.